Hello geometers, this is a demonstration of some of our congruence postulates and theorems. We have two postulates and a couple of theorems. I'm going to just show you a couple of them, and then I'm going to show you one that actually doesn't work. It's not either a postulate or a theorem, and you can't use it to prove triangles congruent. Okay, so first of all, let's go over the side angle postulate. And what that means is if I know that the angle, two angles and the included side, of one triangle are equal to two angles and the included side of another triangle, that if you add on the rest of the parts, you can only add them on in such a way so that the two triangles would be congruent. Let me demonstrate. So what I've done here is copy the the side and two angles, and I'm gonna just flip this over and lay it up here and show you how the only way we can get this triangle or complete this triangle is by creating a triangle that's actually congruent. Okay, so I'm going to extend this side a little bit. I don't have a lot of line to go through there, but I think I can at least demonstrate this. And then add on this line right here. And if you pick up that triangle and compare it to the original triangle, you'll see that the two triangles are congruent. That is the side angle postulate. Here is the side angle side postulate. So this says that if I know two sides and I know the included angle, that the triangle, by adding on the rest of the pieces, the triangle must therefore be, the two triangles must be congruent. So here is my copying of the two sides and the included angle. Again, I'm just going to flip that up over and stick it on upside down. Well, since those two sides are equal, then the only thing I can do is connect the ends of those two sides. And when I do that, then pick up this triangle and compare it to the original triangle, then you see that the two triangles are congruent. Here's the side, and that one's actually provable. So we're going to show it as a theorem. And what I've done here is copy this side right here. You can see that that side's copied. I'm going to put it on up here. And here's another side. And by the time I'm just going to stick that on, I'm going to kind of just stick it on any old way here. And then here's the third side. The third side matches up there. And what I'm going to show you is that the only way those two will fit together, those pieces will fit together, is if the two triangles are actually congruent. So I've got to kind of wiggle this around and wiggle that around until I can show, till I get the ends to meet. And when I do, now you can see that the two triangles are actually congruent. Okay, so I'm going to go back to one of the pieces that I had for this side angle theorem and show you why this one doesn't work. Okay, so here is a side and an angle, and then I'm going to pick up this side right here and I'm going to stick it on this way. Well, if I stick it on this way and extend that side, then it is true that you would get congruent triangles. If I end up drawing that side, you can get congruent triangles. But remember, I don't know how long this side is because I didn't copy that side. But here's what's true, is if I stick this angle on, well, let me first of all extend this side, and then this will be a little clearer demonstration. So I'm going to extend this side. And I don't know what the angle is here. So the angle could be that one, in which case this triangle would be congruent to that triangle. But look at this possibility. This, if I don't know what this angle is, then I have side, side, angle corresponding to side, side, angle. Those are the angles that are equal, and I do not have congruent triangles. So there's our demonstration of 2 postulates, 1 theorem, and 1 that doesn't work.